Travis Gillespie here. Let's go ahead and look at another inequality, an absolute value inequality involving a greater than symbol. And the problem that we'll look at is the absolute value of x minus 8 is plus 5 is greater than, I'm going to start that over, it's looking sloppy. The absolute value of x minus 8 plus 5 is greater than or equal to 11. Okay, so from here, the first thing you want to think, I've got an absolute value and it's an inequality. So the thing that I want to do first is isolate the absolute value. Is it isolated? No, because it's being added to 5. Since it's being added to 5, I want to undo the addition with subtraction. I'll subtract 5 from both sides. Now I could say, hey, these cancel out, and the absolute value of x minus 8, that looked like 81, so I'm making these a little bit more bold. The absolute value of x minus 8 is greater than or equal to positive 6. So once you get to this point, once you isolate the absolute value, all you want to do is think. The thing that you want to think here is the distance from x to 8, distance from x to 8 is greater than or equal to 6 units. The distance from x to 8 is greater than or equal to 6 units. Well, wait a second. Earlier, you were telling me that when we were dealing with inequalities, simpler ones, we were saying the absolute value of x is greater than 5. We were saying, hey, in those situations, I had the absolute value of x greater than 5. What I was saying here is that the distance from x to 0 is 5 units. Now I'm saying the distance from x to 8. What happened to 0? I'll get to that in a little bit. But let's move on from here. When I see that I have an absolute value inequality and the absolute value is actually isolated, and I end up with a positive value, I have two cases. I could think of it as I have a case 1, and I also have a case 2. And it's just two different ways of looking at this inequality or absolute value inequality. And case 1 will keep it simple. Case 1 is going to be the same as the inequality, the absolute value inequality above. So all I'm going to do is drop the absolute value symbols and say x minus 8 is greater than or equal to 6. It's the same thing. And I'm going to fix the 6. That was an ugly 6. That's a pretty 6. Okay, so from here, what could case 2 be? Well, I want to offset it. I'm going to say, hey, in case 2, instead of having a positive 6, I'm going to move in the negative direction and say negative 6. But since I'm using a negative value, I've actually got to flip the inequality symbol. So x minus 8 is less than or equal to 6. That is a negative 6. X minus 8 is less than or equal to negative 6. Moving on from this point, guys. All I want to do is solve for both inequalities here. So the way to do that, I've got to isolate x, the variable. So add 8 to both sides. I know that 8 plus negative minus 8 plus 8 is 0. So really what I have is x is greater than or equal to 14. Now add 8 to both sides here. And I know that x is less than or equal to positive 2. Okay, so now I have my two inequalities that I want to graph. And if I looked at these, it's easy for me to see right now, and it might be a little bit difficult to think about or visualize, but we'll see it in a second, is this is going to be an OR statement. It's going to be an OR compound inequality here. But don't take my word for it. Let's go and graph it. So here's our number line. Let's say this is 0. I don't know. Let's go out. Actually, let's offset this some to where I'm always drawing 0 in the middle. But let's move it to where 0 is off to the left side today. And yeah, we'll say this is -2. And I'll draw my arrows just saying, hey, this is the negative direction still. I'm not trying to trick you guys. Now we'll go. All right, and I'll stop there with the dashes and my marks, and I'll say, hey, this is going to be 2, 4, 6, 8, 10, 12, 14, 16, and 18 units. All right, so let's go ahead and plot our points. Again, the thing that I want to think about from our earlier inequality was the distance from x to 8 is greater than 6 units. Well, let's plot my two inequalities again. And I know that I have a circle or a point that's filled in because x is less than or equal to 2. I also now have a point on 14. So that is also a filled in circle. Okay, so how did I get the distance of or from x to 8? How did I get that 8? Let's go ahead and take the averages of the values 2 and 14. So I'm going to say 2 plus 14 over 2. This is going to give me its average. That equals 16 over 2. That actually gives me 8. Oh, hey, the distance from x to 8, the distance from x to 8 is 6 units. Okay, so what you're telling me is that all I've done, or all that we've done in this inequality, is instead of starting at 0, we've offset it, our midpoint, by 8 units. And that 8 units is right here. This is my midpoint right here at 8 units. All I've done is offset it 8 units. And we can move forward with our points. Because from 8, wherever x is on this number line, it is greater than 6 units from 8. So let's draw this up. Here's 8. Here's 14. And the distance from 8 to 14 is 8 units. Also, this is the value 2. The distance from the value 2 and 8. I got to take this back, guys. I told you that this was 8 units. It's not 8 units. It's 6 units. 6 units. And the distance from 2 to 8, these are also 6 units apart. All right, so 6 units. And what this is telling us is x, the distance from x to 8, so the distance from x to 8 has got to be greater than 6 units. So here's my point right here. And I'm moving greater than 6 units, so I know I'm moving away from 8. I'm not moving towards it. And also, my inequalities are helping me out here. When I'm at 14, x is greater or equal to 14, so I'm moving off in a positive direction. So from 14, my x values are going to be here. And that holds true. These values are greater than 6 units from 8. Also, x is less than or equal to 2, so my units, I am moving in a more negative direction, and they're becoming smaller. Again, this holds true that the distance from x to 8 is also greater than 6 units. So therefore, let's go ahead and draw my compound inequality. And what I have here, as I can see, pretty simple. We've already got it up top, but we're going to make it nice and clean. Starting from the left, I have x is less than or equal to 2. Since these are not connected, I'm going to use the statement or. X is less than or equal to 2, or x is greater than or equal to 14. And now it's easy to visualize why I use the or statement.